Section 5.3, we're going to be adding and subtracting rational expressions. Alright, so when we add and subtract rational expressions, very similar to when we work with fractions, where we need to get common denominators. Alright, so here's our first example. Okay, we're given one where the denominators are the same. So just like when you add fractions, you're going to add the numerators, and then the denominator stays the same. So if we just go through and add the numerators, let's see, we get 2x minus 5. Okay, and then that is our answer, 2x minus 5 over x plus 4. And then it says identify any x values for which the expression is undefined. So we need to look at the denominator. Alright, and we know that the denominator cannot equal 0, so x cannot equal negative 4. Alright, here is one where the denominators are the same, except now we're subtracting. Alright, so what we want to do, 3x minus 4, we want to make sure that we subtract the second term, and we need to distribute the minus sign. Okay, so we're going to write this as 3x minus 4 minus 6x minus 1. Alright, so let's see, 3x minus 6x is negative 3x minus 5 over x squared plus 1. Alright, so now we're getting into the problems where the denominators might not be the same. Okay, so if the denominators are not the same, what we need to do is find the least common multiple of polynomials, and in order to do that, we need to factor. Okay, so let's just take a second, review the least common multiple. So if we look at 4x squared and y cubed, 4 is 2 times 2, and then we can have x squared and y cubed. Then if we look at the next one, 6 would be 2 times 3, x to the 4th, y to the 5th. So the least common multiple, we would take both 2's from the 4, we would take the 3 from the 6, and then the x to the 4th, y to the 5th, because those are the largest exponents. Okay, and that would be our least common multiple. Very similar with a polynomial with adding and subtracting, we need to factor. So this factors into x minus 3, x plus 1, and this one factors into x minus 3, x plus 2. So the least common multiple would be x minus 3 times x plus 1 times x plus 2. Alright, so let's look at this addition problem, and what we need to do first is factor this denominator. Alright, so this is x plus 4, x minus 1. Okay, so what we can see is that the second fraction needs an x minus 1. So what we can do is multiply the top and bottom by x minus 1. Okay, make sure you have to do the top and bottom, because this is just like multiplying by 1. So we're not changing the value of the expression, we're just multiplying it by a form of 1. Alright, so this is x minus 3 over x plus 4, x minus 1, and then this is going to become 2x squared minus 2x over x plus 4, x minus 1. Now that the denominators are the same, we can just go ahead and add the numerators. So we're going to add our like terms. Let's see, the 2x squared is going to stay. Then we have x minus 2x, which is minus x. And then we have minus 3 over x plus 4, x minus 1. And you don't need to multiply this out on the bottom. You can leave it in its factored form. Okay, and then the x values, x can't equal, let's see, negative 4 or positive 1. Okay, for the next one, again, we're going to add, and first thing we need to do, let's factor the denominators. So let's see, that's 2 times x minus 1, and this would be 3 times x minus 1. So they both have an x minus 1. So what we need to do is multiply the first one by 3 over 3, and the second one by 2 over 2. And that's going to give us a common denominator. Alright, so we get 9x over 6 times x minus 1 plus, let's distribute that 2, 6x minus 4 over 6 times x minus 1. Now that the denominators are the same, we can add the numerators, and we're going to get 15x minus 4 over 6 times x minus 1. Alright, and looking at the bottom, x cannot equal 1. That would give us a 0 in the bottom. Okay, our next example, we're going to approach this the same way and factor out the denominator. Let's see. Let's take this 2 out of here as well. 2 times, what's that become? X plus 3. Alright, and the bottom is going to be x plus 3 times x plus 3. Alright, and then it looks like these will cancel out. That's nice. And now we have a common denominator. So this equals x plus 2 over x plus 3. Okay, and then x cannot equal, let's see, we look at the denominator, negative 3. Alright, our next example, similar problem except now we're subtracting. Alright, so let's do 2x squared minus 30 over, let's see, that's x plus 3, x minus 3. So it looks like our second fraction needs an x minus 3. We're going to go ahead and multiply the top and bottom by x minus 3. And let's see, we have to distribute all of this, so x squared minus 3x plus 5x minus 15 over x plus 3, x minus 3. Alright, now let's add our like terms. Actually, you know what might be better? To distribute the minus sign. Alright, so minus, plus, minus, plus. Okay, the negative sign goes in and changes all the signs. Alright, so we have 2x squared minus x squared, that's just x squared. Let's see, our x's are going to be minus 2x. And then we have negative 30 plus 15 is negative 15 over x plus 3, x minus 3. Alright, and we're not done yet because if we notice the numerator, we can factor this. This is, let's see, multiples of 15 are 3 and 5, so we want the 5 to be negative. so that they add up to -2. And then our x plus 3's cross out. And this simplifies x minus 5, x minus 3. Alright, now the values that x cannot equal, we have to look at all of the problems. So x can't be plus or minus 3. Okay, it can't be -3 from here, +3 from here. Alright, next we're going to look at complex fractions. Alright, so there's fractions all over the place, in the numerator and the denominator. Alright, and we're just going to go through and talk about simplifying them. Alright, the first one here. Multiplying by the reciprocal is the same thing as dividing. So we have x plus 2 over x minus 1 times, flip that around, x plus 5 over x minus 3. And now, just like fractions, we're going to multiply across x plus 2, x plus 5 over x minus 1, x minus 3. You don't need to multiply everything out. You can leave your answer just like that. Alright, next. What we need to do first is simplify this top part here. Alright, so we need to get a common denominator. So we're going to multiply this one by 2 over 2, and this one by x over x. Okay, so we're going to get 6 over 2x plus x squared over 2x. And then just keep that bottom the same. And let's see, x squared plus 6 over 2x. Okay, you want to write the x squared first, just so it's in standard form. Then what we're going to do, instead of dividing by the fraction, we're going to multiply by the reciprocal. Okay, and let's see, looks like these x's will cross out. So we have x squared plus 6 over 2 times x minus 1. Alright, we can leave our answer just like that. Alright, we're going to finish up with a nice word problem. Alright, what we want to do first is let D equal the distance one way. Okay, he's traveling the same distance, it's going up and then down. But he's going up the same distance as he's going down. Alright, so the total time, let's say the total distance first. Total distance traveled, since he's going up and down, would be 2d. Alright, and remember, we're still working with d equals RT, right, rate and time. And we're going to do the total time next. So if we switch these around, time would be distance over rate. Alright, so let's look at the total time. That would be distance over his first rate plus distance over his second rate. Alright, so the question is asking for the hiker's average speed for the entire trip. Okay, so now we have enough information for the average speed. It's going to be the total distance divided by the total time. And what we need to do is simplify this, and we'll get our average speed. Now I think it's going to be easier for us if we change this decimal into a fraction. So this is really d over, if we do 1.4 as a fraction, it's 7/5. And 0.8 as a fraction is 4/5. I know, we're getting all kinds of fractions in here. So we have 2d over, so this is actually going to be 5d over 7, right? We're going to flip that around, plus 5d over 4. Now, similar to the last problem, we need to get a common denominator here before we can move on. So it looks like the first one's going to need a 4, the second one's going to need a 7. So we're going to get 20d over 28 plus 35d over 28. Let's see, 20 plus 35 is going to give us 55d over 28. And now let's flip that over. 2d times 28 over 55d. Cross the d's out. And we get 56 over 55, which, if we put in our calculators, is about 1.02 miles per hour. Okay, so that's his average speed over the trip.